So we make our way over to Twin One, everyone. His investment grows like an annuity to begin with because he is making regularly scheduled payments of $2,000 at the end of each year for 8 years. And after that, no additional contributions are being made to the fund. So that is going to begin growing like a compound interest situation as soon as he stops making payments. So let's take a look, and we see there that we do have a future value of annuity formula and we have a compound interest formula. So we are going to have to set those both up for this problem. And so I will do my SERMTIN for the first one, which is going to be the annuity. And we've got that we don't know the future value, so that's what we're looking for. He's putting in $2,000 every year. The rate is 10%, so 0.10. M is compounded annually, so 1. T, he only put it in for 8 years. He only did this for 8 years. And the I is R over M. So we've got 0.10 over 1. This is going to be 0.10. And N is MT. So we've got 1 times 8, which is 8. And so I won't make you sit through me writing that nasty formula again. Well, it won't take me too long. So we've got S equals R times 1 plus I to the power of N minus 1 over I. And for this, everyone, what's going to end up going into Wolfram is we're going to be putting 2,000 in for R. 1 plus I, so 1 plus 0.1 to the power of 8 minus 1 over I. And we'll give that to Wolfram. We'll see what we come up with that. So I'm just going to use the same one that I already had in here from the other twin, and all I need to do is change that 35 to an 8 because this twin only did it for 8 years. And so this twin right here only has a whopping $22,871.78. And I don't know why my iPad disappeared. I'll pause the video and fix that and get it back up here. Oh, the universe is fighting against me getting these videos done today, everyone. So this twin has $22,871 in the account when he is 30 years old, which doesn't seem great when compared to twin 2, who ended up with $472,000. So at this point, twin 2 would be like, really letting his brother have it, like, hey man, I really got it. I did the awesome thing and I tore it up. So let's go and continue with twin 1 from the time he's 30 years old to the time he's 60. This money is going to stay in that account and grow by compound interest. And so for the compound interest portion of this, everyone, we do need a new formula. So we are going to redo SERMTIN. And so we don't know what the future value is. The lump sum, because the payments stopped, now this is doing compound interest, the lump sum that is left in the account to grow is $22,871.78. The rate is, everything else is the same. Rate is 0.10. M is still compounded once a year. T, it's going to sit in there for 35 years because he's going to leave it in there from the age 30 to 65. I is R over M, and N is MT. 0.10 over 1. MT is 1 times 35, so 35. And so our compound interest formula is S equals R times 1 plus I to the power of N. So we're going to swing in Wolfram. S equals 22,871.78 times 1 plus 0.1 to the power of 35. And I can just copy my formula from right here and get it into Wolfram, and we'll be on our way. So For the initial investment, it's $22,871.78. The I is zero point 0.1, and the N is 35 years. So twin 1 ends up with a total of 642,752.75. So if we were to compare these two twins, everyone, this guy ends up with 642,000. Let's go ahead and just finish the statement about this guy. What did I write about twin 1? Twin 1 turned 16,000. Okay. So twin 1 turned the initial investment of $16,000 into $642,752.75. So he gained, how did I word it over here, everyone? He gained about, okay. He gained about, and if we subtract 16,000 from that, what would we have? We would have 626. He gained about $626,000 for doing nothing. And so Twin 2 was able to turn $16,000 into 642. Twin 1 was giving, or Twin, so getting these twins mixed up. This guy was able to, who started first, Twin 2, was able to turn $16,000 into 642,000. The other twin, who thought that he was going to come out ahead because he invested so much more money, ended up at 542. So there is a $100,000 difference between these in favor of the twin that invested less money. And the reason for that, everyone, is because, as we've said multiple times throughout the course, time is fertilizer for money. And so this $16,000 beat this $70,000 by 100,000 bucks, because it was the investment started 8 years earlier. And so if you're a person that is wondering when the right time to start investing or putting into a retirement account or whatever account you want to put into, the answer is yesterday. So now.